In this video, we're going to be talking about section 2.1, rates of change. This is going to be day 2, or part 2. And today we're going to kind of redefine the rate of change, and we're going to give it a new name, and that name is the slope. So, as it says right here, another name for the rate of change of a line is its slope. So we had talked about yesterday in a previous video that the rate of change is the change in the independent variable and the dependent variable. Specifically, it was the change in the dependent over the independent. And in science, we often use the symbol for delta to mean change. So change in the dependent over the change in the independent. But since the dependent is also the vertical axis, then we know that we're really just talking about the change in the vertical, and the independent is the horizontal. So vertical change over horizontal change. One way you'll hear that summarized is just a quick little, I guess a mnemonic device to try to help us remember is we do the rise over the run. It's the vertical change over the horizontal. So how much does it go up, the rise, and then how much does it go over the run, like a runway is horizontal, right? Rise over run. Okay, so when we look at this example 1A, finding the slope just using a graph, it is as simple as just counting. So, but what we have to pay attention to is the direction that we're going. So when I look at this, if I decide to figure this out by starting at this point right here that is labeled kind of in red, let me change my color here. If we start there, then it clearly, to get from that point to the second point, we go up 2 units. We count up 1, 2 to get up to the height of 3. And then we go over 1, 2, 3, 4, 5 units. So it's up 2 and to the right 5, both of which are in the positive direction. We're going up and we're going to the right. So we would say the slope is equal to 2, the rise, over 5, the run. And that's it. All right, let's go and look at B. This time we are going up again, so our slope is going to be a positive number. And so we can just count how far up it is. 1, 2, 3, 3 units up. Okay. And then 1, 2, 3, 4, 5 units up. So this time it is a vertical change of up 3. And then to the right, which is positive, what do we say? 1, 2, 3, 4, 5. Here, my slope, this time, if we look at it going from this point over here and going to this point, so moving from the left to the right, then it seems pretty obvious to me that we go down 1. So we go negative 1, 1 in the negative direction, and then 1, 2, 3, 4, 5, 6. So my slope on this one is going to be down 1 and over 6, which gives you a slope of negative 1/6. We hopefully know that negative 1 divided by 6 is equal to the same thing as 1 over negative 6 for that matter, but really it just means it's negative 1/6. So that's why when it went down 1, positive 6, I just treated the whole thing as if it was negative, because 1 negative makes it negative. All right, so pretty simple as long as you keep it straight in your head that we're looking for the vertical change over the horizontal change, and pay attention to up or down, then it's really quite simple. All right, so my slope is negative 1/6. Okay. However, we don't always want to count, or sometimes it's not countable. For example, there could be possibilities where our points are really ugly decimal points, and then it makes it very difficult as a counting exercise. So we need to come up with some math that we can do so we don't have to have a graph. And so once again, when we think about slope being the rise over the run, we can think about how do we find the total distance. So let's kind of rethink the three problems we just did, but now let's do it more algebraically. So if I want to find out how far it is of a rise, so I want you to think about this for a minute. This whole change here from the, if we start at like thinking about at 0 as the bottom, this change, that's a whole height of 3. And this is a height of 1. And so if I want to find out what's left over when I go all the way up to 3 and I look at 1, then what I'm looking for is the difference between those two heights. So it becomes 3 minus 1. So if you want to find the vertical change, we just need to figure out how high does it get minus how low does it start. And so in our case, we're going to do simply y2 minus y1. So the y value of one of the points, 3, minus the y value of the other point, 1, and that gives us a value of 2. And then if I want to find out the x's, then I want to figure out how far it is between the x's. So I'd go to x2 minus x1. And so my second point is at 4. So this is a distance right here of 4. And I'm going to subtract this distance right here, which is negative, I went too far, negative 1. So 4 minus negative 1 makes 4 plus 1, and I get 2/5, which is the same answer we had before I erased it. We went up 2 and over 5. So on this one, we could do the same thing, y2 minus y1, the vertical change over x2 minus x1. That'll give you the horizontal change. And so I've got the point up here at 4 minus the y value of 1 over the x value of 3 minus the x value of negative 2. We cannot drop a negative. We have to do what it says. So finding the difference between two things, you subtract them. Whether one of them is negative or not, we include all the negatives in the problem and we just do the math. So 4 minus 1 is 3. 3 minus a negative 2 is 3 plus 2, which is 5, which is what we said it was by counting. And then finally, if we do y2 minus y1 over x2 minus x1, then I've got a height of 1 minus, where do we start with? A height of 2 over 3 minus, and where do we start? Negative 3. So 1 minus 2 is negative 1. 3 minus a negative 3 is 3 plus 3 is 6. And we get our same answer of negative 1/6. We go down 1 for every 6 units. All right. So what that means is we don't have to have a graph to answer these questions. So let's take a look at these 4 problems here. Find the slope of the line that goes through these given points. So I don't even need to worry about a graph. We can confirm it with a graph if we want to, but all I need to do is just know that slope, which is abbreviated as M for reasons I don't remember, y2 minus y1 over x2 minus x1. Now, for the record, it does not matter which point you call the first point and which point you call the second point. It does not matter at all. You just have to be consistent. So probably for at least the first couple of weeks of doing things with slope, I will probably always, just to be consistent, I will probably call the second point written down as 0.2. And I'll call this one 0.1. But again, I want to be clear. It does not matter which one you call which, as long as you're consistent. So y2 is 7 minus y1 is 1 over x2, which is 5, minus negative 2. So I'm going to start writing it this way. I'm going to write 5 minus, because that's in the formula, right? 5 minus. And then I'm going to go look at the number and see that it's a negative 2. And I'm going to put my second negative vertical to turn into a 5 plus 2, because minus and negative makes plus. If you want to keep writing it out as we did in the first example, where we do 5 minus a negative and then convert it, by all means, go ahead and do that. 7 minus 1 is 6. 5 plus 2 is 7. Looks like I have a slope of 6 over 7. All right, part B. My slope is y2 minus y1. I'm just going to keep writing it, because the more I write it, the more I'll quickly memorize it and get it right. I'm going to do 7 minus 5 over 4 minus 2. 7 minus 5 is 2. 4 minus 2 is 2. And so up 2 over 2, or that just reduces to a slope of 1. Meaning, what does that mean? Up 1 and over 1, right? Because 1 is 1 over 1. Okay. Maybe let's just take a quick moment and just kind of just double check our math on these, make sure that they're doing what we think they're doing. So I'm going to just graph this last one. 2, 5. All right, 2, 5 is going to be 1, 2, 1, 2, 3, 4, 5. That's right there. And 4, 7, 4, 7. And so we have a line if we connected them. And what did we say the slope was? 1, meaning I go up 1 over 1, and I should hit the line. Up 1 over 1, and I hit the line. So we don't need the graph to get these right. Certainly, it's a way you can double check yourself. All right, let's do 2 more. My slope is, I'll just write the formula again. And my slope is going to be negative 2 minus and a 4 over 3 minus, and it's a negative 1, so my minus is going to turn into a plus 1. So I get negative 6 over 4, which can reduce to negative 3 over 2. So this one looks like we should be going down 3 and over 2 based on the math. So let's check this one as well, just to see it happen. All right, negative 1, 4. Negative 1, 1, 2, 3, 4. That's here. And 3, 1, 2, 3. Negative 2, 1, 2. And we're saying that we're going to have a slope of negative 3 halves. So 1, 2, 3 negative, 2 positive puts me there. 1, 2, 3 negative, 2 positive puts me there. That's why saying the slope of negative 3 halves. But remember, before we reduced it, we said it was negative 6 fourths. That would have been 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. And we still end up on the same line. Okay, and this last one, we've got my slope is equal to y2 minus y1 over x2 minus x1. So my slope equals d minus b over c minus a. I don't know what a, b, c, and d are, so I really can't do anything more with it than that. That would be my slope. Okay, and then what do we have left? I think we've got a couple special cases to talk about, and then just a quick review. So find the slope of the line that passes through these given points. So once again, m equals, practice it, y2 minus y1, x2 minus x1. So my slope is going to be 2 minus the other y value is 2. Interesting. and that's 4 minus 1. So I get 0 over 3, and 0 divided by anything is just 0. So it looks like my slope is 0. Let's graph these and see what's going on. I've got the point 1, 2, and I've got the point 4, 2. 2, 3, 4, 1, 2. And if I connect these with a line, I can see that we're talking about a horizontal line. And so we're saying the slope of the horizontal line is 0, meaning I start at any point on the line and I go up nothing and I go over. It doesn't matter how far over, because whether I go over 1 or a half or 3 or anything, I'm going to get points that are on that line. So having a slope of 0 means up nothing and over whatever you want, right? Because it doesn't matter. So that has a slope of 0. All right, let's take a look at this next one. Y2 minus y1, x2 minus x1 equals, what do we got? Negative 1 minus 2 over 4 minus 4. That gives me negative 3 over 0. Before I do anything with that, let's graph it, see what it looks like. 4, 2, 1, 2, 3, 4, up 2, and then 4, negative 1. So if I connect those, I get myself a vertical line. Now, this does not equal 0, because if it equals 0, we just talked about that makes it a horizontal line, but this is a vertical line. This is saying that to get from this point to this point, I go down 3 and I go over nothing. The issue is, and this is something we'll be continuing to drum into your head over the years, is that you cannot divide by 0. So anytime we have this vertical line situation, or anytime that we have our horizontal change is 0, we need to equate that to that, oh, that's a vertical line. And its slope is what we would call either undefined, because if you grab your calculator and do this math, you're going to get an error, or we would say there's no slope. Okay, so this is something just to kind of understand. Number one, hopefully at this age, you know that you can't divide by 0. And so once we're set up in this situation where we divide by 0, that just needs to be a little clue in our head that, oh, this is a vertical line. And it doesn't take long if you just, again, graph the points to see that, in fact, it is a vertical line. So slope of all vertical lines are always no slope. Slopes of all horizontal lines are always a slope of 0. All right. And that's not something you're going to just kind of remember unless you make a point to memorize and come up with a way to remember it. Okay, so just to summarize, here's what we know about slopes as of right now. A line with a positive slope should go up as we move from left to right. As our independent variable gets bigger, our graph gets taller. So it has a positive correlation. A line with a negative slope has a negative correlation, meaning as my independent variable gets bigger, what happens? My dependent gets smaller. A line with a horizontal line has a slope of 0, and a vertical line has an undefined slope. Okay, that is it for slope for today, and we will see you in class.